Hello, my name is the Math Raccoon, and I changed my my username on my YouTube channel, so I'm now known as the Math Raccoon rather than the Math Train. And let's begin. So today we're going to be working on the tangent ratio. If you don't know what the tangent ratio is, it's basically the tan function in the expression SOHCAHTOA, and SOHCAHTOA has to do with right-angled triangles. As you can see here, I colored a little bit so you can know which one is which. So SOHCAHTOA is sine theta equals opposite over hypotenuse, and then ka would be cos theta with adjacent over hypotenuse, and then we have tangent theta, which is opposite over adjacent. And those are our primary trig functions. When we're dealing with questions, we always need unit measurements. And as you can see from the diagram down here, my points are labeled A, B, and C. And then we have theta right here with our adjacent side length, 2 theta, and then our opposite side length, 2 theta, and then our hypotenuse as well. We also have inverse trig functions. You can find these buttons on your calculator, and they help us get the value of an angle. And today we're going to be focusing on tangent ratio, tan theta, or TOA in that phrase SOHCAHTOA. Alright, thank you very much, and let's begin. So we have our diagram right here and our information right here. So I just put that at the top just in case you needed it to remember. And we are going to be calculating tan C along with this note right here. So all side lengths must have unit measurements. If none, state units as its measurements. So here I have 9 units and 5 units. So with side length, so this would be A, this would be B, this would be A, this would be C, and this would be B. All side lengths must have measurements. And so if there are no measurements, just put units, and then that will be okay. So, we have theta right there, theta right here, so it's tan C that we're solving for. We have our original formula, tan C equals opposite over adjacent. So right here we have adjacent, and right here we have opposite, and right here we have hypotenuse. So we have tan C is opposite over adjacent. So we have tan theta equals, so we're going to input our values of opposite and adjacent into the formula. So we have 9 units over 5 units. And then we have theta, which is, we'll take the inverse function of tan multiplied by this fraction. And then we have our answer, which is 60.95 degrees, or theta would be 61 degrees. Tan C or angle C is valued at 61 degrees. And we will be circling our answer in green. So that's our therefore statement as well. Alright, moving on. So again, we have our information up here, a little cheat sheet, a diagram that shows theta with adjacent side, opposite side, and hypotenuse side. And we have we have 7 units, 3 units, and then our hypotenuse. So we have our hypotenuse. And then we have our adjacent. And then we have opposite. So when it comes to labeling the sides as hypotenuse, adjacent, opposite, it has to do with which angle you're finding. So with this theta, the side adjacent to theta would be right here. And then the side opposite would be right here. And then we have our hypotenuse, which is our longest side. And let's begin. So we have our tan C equals opposite over adjacent. And that's our formula. And then we'll go tan angle C. We're going to input the values of opposite over adjacent. So we have 7 units over 3 units. And then we have angle C. We're going to take the inverse of the tan function. And we'll go 7 over 3. And then with angle C, it will be 66.80 degrees. And if we're rounding to the nearest degree, it would be 67 degrees. Sorry, I'm just going to circle our answer and circle our answer in green. And then we have our therefore statement. Tan C or angle C is valued at 67 degrees. And then we'll circle our therefore statement. And there you go. So that is question B. And let's move on. So we have, again, our cheat sheet on the top here. And then we have our formula and our diagram with units, unit measurements. And we will be going away. So tan theta. And we're going to input the values based off of this theta right here. So this would be adjacent. This would be opposite. And this would be hypotenuse. So we have tan theta. We're going to input the values of opposite and adjacent. So you can see here, this is our adjacent value, and this is our opposite value. So we have our opposite value, which is 11 units. Then we have 4 units. And then we have angle C would be, we're going to take the inverse tan function with 11 over 4. So we have angle C or theta. And then with that, with the inverse tan function being multiplied by 11 over 4, our answer is 70.02. And then our angle would be 70 degrees. And then we're going to do our therefore statement. And we have tan C or theta or angle C is valued at 70 degrees. I'm going to take our green here, we're going to circle our answer, and then our therefore statement. Let's try that again. We're going to circle our therefore statement. Alright, moving on to the next question. So again, we have all the information that you need right here, and with a diagram to help you understand the concept of the tangent ratio. As you can see here, it's boxed in a little cube. It has to do with right angle triangles, and we're gonna get into like if a triangle doesn't have a right angle, we're gonna just learn how to handle and find the measurements of those triangles. So we have the primary trig function. We're focusing on tan theta equals opposite over adjacent. We know that it has to do with which angle you're finding in the triangle. So if you're finding angle C, this would be the adjacent side, this would be the opposite side, and then this would be the hypotenuse. Let's say if you're finding angle A, then this would be the opposite side, and then this would be the adjacent side, and then the hypotenuse would stay the same. But it has to do with the theta that you are finding. So this would be the adjacent side, this would be the opposite side, and this would be the hypotenuse. So we're finding tan C. We have our units right there. We're finding tan C, so this would be adjacent. This would be opposite. So opposite side. And then we have our hypotenuse. Alright, so we have tan theta, and we're going to input the opposite value, which is 5 units, and in the adjacent value, which is 12 units, and then we have angle C. We're going to take the inverse of the tan function, 5 over 12, and then we have angle C, which is 22.62, and then our angle rounded to the nearest degree, which is 23 degrees. Sorry, green. And then we have our therefore statement. So tan C or theta or angle C is valued at 23 degrees. And then moving on. So, okay, so this one, we're going to be calculating in each triangle, calculate tan A and tan B. So, we're going to show you how to calculate tan A and tan B. It's a lot simpler than it seems, so just bear with me. So with tan A, right here, this would be the adjacent side, and this would be the opposite side for tan A. So let's do that now. Tan angle A equals 9 centimeters over 15 centimeters. And then we have angle A, tan the inverse function, 9 over 15, and that would equal 30.96 degrees, it would equal 31 degrees. And we will circle that later. And then we have tan B. So this would be the opposite side, and this would be the adjacent side. So here adjacent, here opposite. So right here would be the opposite, and right here would be the adjacent. So let's do it. Tan angle B equals 15 centimeters over 9 centimeters. Then we have angle B. We're going to take the inverse of the tan function, 15 over 9. And then we have angle B being 59.04 degrees. Angle B being 59 degrees. Okay, so we have orange. We'll circle that. We have yellow. We'll circle that. And then do our answer. Angle B equals 59 degrees. And angle A, which would be 31 degrees. And we'll circle that in green. So that's our answer, and that's our therefore statement. So we're going to try more questions like this in the upcoming questions that we have. We're going to be calculating tan A and tan B. So it's going to be easier as we go on. All right. So we have tan A. So this side would be the opposite side, 9 centimeters. This side would be the adjacent side, 6 centimeters. So let's calculate that. So we have tan angle A, and we have 9 centimeters over 6 centimeters. Angle A, we're going to take the inverse of the tan function, 9 over 6. And then we have angle A, which is 56.31 degrees. Rounded to the nearest degree would be 56 degrees. And we'll circle that. Okay, and now we go to angle B. So with this side would be the adjacent side. And then arrow there. This side would be the opposite side. And that's 6 centimeters and 9 centimeters. So this, it's just with the angle pointed at the opposite side, and then this would be the adjacent side right next to the angle. And then this with the arrow would be the opposite side. Alright, let's begin. So we have tan angle B. We're going to input our values for opposite and adjacent. We have angle B. We're going to take the inverse of the tan function, 6 over 9. Angle B would be 33.69 degrees. Rounded to the nearest degree would be 34 degrees. And we'll color that in orange. And now we have our therefore statement, angle A being 56 degrees and angle B being 34 degrees. And we'll circle that in green. Okay, so that was question B. And then we're going to move on to question C. Alright, so this diagram is just flipped. So when we're calculating tan A, the side across from the angle is the opposite side. When it is touching the angle or near theta, it would be the adjacent side. So we have tan angle A being opposite 19 centimeters over 22 centimeters, opposite over adjacent, angle A. We're going to take the tan inverse 19 over 22, and then angle A being 40.82, and then rounded to the nearest degree would be 41 degrees. And then we'll circle that in yellow. Alright, so we have angle B, or theta B, and then with theta B, across of being the opposite side would be 22 centimeters, and then the adjacent side touching the angle would be 19 centimeters. So we have tan angle B. We're going to input the values of opposite over adjacent. And we have angle B being tan negative inverse function of tan, 22 over 19. And we have angle B being 49.19 degrees, and rounded to the nearest degree would be 49 degrees. And we'll circle that in orange. And then we have our therefore statement. So we have angle A being 41 degrees and angle B being 49 degrees. And that is our lesson. And that's our final answer and our therefore statement. And that is my lesson for today. I hope you had a good time. I hope you learned a lot. Again, this is the Math Raccoon, and I hope that you found this helpful. Thank you, and bye.